Hey, this is Brent with Lykins Motorsports. What you're seeing on the screen is a 449 cubic inch Ford FE that is set up to make 664 horsepower. So this is another one of my featured builds, and we're going to go through a lot of photos and information and then show you the dyno sheet and a dyno pull at the end. This is for a customer of mine in Arizona who wanted to road race an early model Galaxy, and the car was set up for an FE, so he wanted to put an FE back in it and wanted a good solid engine to road race with. So let's get into the specifics, and as always we'll start out with the block and the machine work. Alright, so for this build we decided to use a BBM block. This build is a couple of years old, but the results still speak for themselves. So BBM cast iron block, 4.350 bore size, and I went to Scat and had a crankshaft custom made with a 3.78 stroke and a big block Chevrolet rod journal size. So the combination of that bore and stroke gives me 449 cubic inches. For the connecting rods, we used some K1 rods, and Racetech got the nod for the custom forged pistons. You can see those right there. Just a small dish, and we were sitting at about 11.5 to 1 compression. So for the piston rod combination, again, Racetech pistons, and we went with a 6/800 rod size, which gives us a 146 compression height on the piston. We wanted something with some stability to it, to give us some longevity for a road race engine. If you'll notice, we used, since this was a dry sump motor, we used some Trend tool steel wrist pins that have been DLC coated. There's a shot of the assembled short block with all 4 pistons in on that side. So for a solid roller engine, we drill, or well, you don't really have to drill, you could tap the holes underneath those crossed pipe threaded holes in the back there of the lifter valley, and we install a 1/8 pipe plug that's been drilled for a restrictor to restrict the oil to the lifter galleries. There's a shot of piston valve clearance. We had plenty. And I was wrong. Those are diamond pistons, not Racetech. Sorry about that. There's a shot of the Cloy's billet steel timing set that I like to use, ARP cam bolt. The camshaft is a custom solid roller camshaft, not as much duration. And we move to the exciting part, the cylinder heads. Believe it or not, I used Trickflow heads right out of the box. Bought them bare with valves. Milled the pedestals down so that we could use a T&D paired rocker system, and then installed my own valve spring package to match the camshaft, which basically included Manley valve springs, the titanium retainers. Can't stress enough how awesome those heads are, and you'll see how much horsepower we made here in a minute. But with a standard out of the box Trickflow head, 175cc intake port, 2190, 1625 valve package, about 330 CFM of flow. We do port these, and we get about 360 CFM out of them. Wasn't necessary here, but just an excellent cylinder head. Too bad they're out of stock right now. There's a shot of mock-up, and the intake that we used is a Trickflow track heat intake manifold that was designed for use with their cylinder heads. This one's been ported by Joe Crane. Excellent intake manifold, and it's a great combination of parts if you want to make some horsepower. There is another shot of the intake, and you can see the sub bar for the T&D paired rockers. That sub plate is held to the heads and the block by head bolts. So everything is as rock solid as you can possibly get it. Then each rocker arm is just one pair intake rocker, exhaust rocker, held on separately. There's a shot looking down the lifter valley of the BBM block. Got the Morel lifters sitting in there, and the Cometic intake manifold gaskets that have already been greased up with some Dow Corning 732 clear silicone. I've already laid my end rails there, getting ready to set the intake manifold down on the block. There's a shot of a little bit further assembly. We've got the AVA dry sump oil pan on the front motor plate that will, as you'll see here in a second, will hold the oil tank and some other goodies. We've got a CVR universal water pump body using the FE Power water pump adapters. So those water pump adapters allow me to use a factory alternator bracket, as well as any other accessory that you would normally bolt to the water pump on an FE. Good shot there of the subplate on the T&D rockers and the track heat intake manifold. There's a front shot of the motor plate. This had to be basically installed on a mock-up engine in Arizona on the car, just so that we knew everything would fit. You can see the plethora of holes in there that have been drilled and clearanced and cut just to make sure that it fit inside of the Galaxy engine compartment. This was an extremely challenging setup to get all the dry sump components in that car, dodging everything that was in the car, front cross member, that sort of thing. So you'll see here in a second how we had to do everything. There's a good shot of the rocker arms. Again, T&D paired. We call those the race rockers. Bulletproof as it comes. Got a gauge on the back side of the intake manifold. That's a vacuum gauge, so we can see how much vacuum our dry sump pump is pulling. A good dry sump pump does a whole lot more than pulls the oil out of the engine into the tank. It will also create vacuum in the crankcase. I've never had any issues with the AV8 stuff not making vacuum. This engine pulled 15 inches of vacuum right off the bat. So engine was sealed up well. AV8 pump was really, really good and efficient, and a lot of crankcase vacuum there. MSD distributor got some big old fat Moroso plug wires, and we'll go on to the next series of pictures here where I'll show you the oil pump and everything else. So there's the business end of the oil pump. You'll see that AV8 mounts their dry sump pump pulley into the balancer spacer on an FE. We were able to mount the pump on the passenger side of the engine and got the belt alignment nailed down. Again, this was one of the most challenging dry sump installations I've ever had, just in terms of fitment. Everything had to be tucked in very close to the block, and we shipped parts back and forth to be mocked up. Lots of measurements were taken, lots of funky fitting sizes and all that sort of thing, just to make everything fit. Everything come up looking like a big bundle of snakes. See, we got a PowerMaster alternator. We've got our remote filter mounted to the motor plate and our dry sump tank there as well, and just a lot of hoses. So the alternator had to be mounted on the passenger side, which took up room for our tank. So our tank had to be mounted on the driver's side. So just a lot of hoses crossing left and right. If you're an nostalgic FE fan, you'll note the Mickey Thompson valve covers. We needed valve covers that didn't have breathers, because you do not want anything that could leak into leak vacuum. So valve covers, no breathers, allows the vacuum pump, the dry sump pump, to pull as much vacuum as it possibly can. It's a front shot of the engine there, again showing how everything is laid out. Usually we end up spending somewhere around $400 or $500 on just AN hoses and fittings by themselves. And there's a shot from the driver's side showing the valve covers, those big fatty plug wires, and our little vacuum gauge on the back. What's nice about the dry sump pumps is that you can easily slip the belt off and take a speed handle and prime that pump. So you can essentially never ever have a dry start. Then there's the shot of the engine on the dyno, all hooked up and ready to go. And nice little 850 custom carburetor there on top. And I want to show you a dyno video. Now we didn't get a video inside the dyno room like I usually do, but got one through the glass, and you can really hear the engine run. And if you want to hear some goodness, you can hear that the exhaust pipe slipped off the headers at the end when the engine got really loud. Let's listen to it one more time. It's always my favorite when the exhaust pipes slip off. It is such a glorious sound. So let's look at the dyno sheet. And first thing, we look at the oil temperature, and we just gained a couple degrees. We're in good shape there. Water temperature stayed at around 165 degrees. Oil pressure went up throughout the pull, and air fuel ratios were very close to each other. That's one of those results of a good ported, balanced intake manifold. Air fuel ratios are the same side to side. On the torque, we got 613 pound-feet of torque. And look at that horsepower number, 664 horsepower at 7,000 RPM. So let me grab my phone here, do some calculations. 664, we were at 449 cubic inches. It's 1.48 horsepower per cubic inch. That's a very stout Ford FE. And especially for out of the box Trickflow heads and such a small displacement. So again, excellent cylinder heads, excellent cylinder head, intake manifold, camshaft package, and just did a world of good there. Alright, I wanted to thank you guys for watching this video. I appreciate you all very much. Appreciate the traffic and the subscriptions and all the likes and the views. And thanks for taking your time, taking time out and watching another episode of the channel. Don't forget to check out the t-shirts that are for sale. Got a few different flavors, some with just Lykins Motorsports, some with Project Junkie Junk Junior, our little 302 that we should be hopping on back onto here in a few weeks. I'm waiting to take down Mr. Jim's 464 cleaver, and since it's a small block, I'll probably take down a couple at the same time. But once again, thanks for watching, and hope you're having a good week and a good weekend, and I'll talk to you guys soon.